Hello. Okay, there's people coming in now. Anyway there, can you see the desktop? Do you hear me? Does everything seem okay?
Yep.
Okay, great. Thank you. Okay. I'm gonna wait a second while only about half the people are in. People are, that Brightspace or Zoom is letting them in now. So hello, hello, hello. Good afternoon. People are still coming in. Okay. Okay, so today we're going to start looking at, remember last week's reading assignment was about pointers, and I gave a pretty big number of references for pointers and said to read at least one of them. And as we go along, you might want to dip into some other ones. We're going to start talking about how pointers get used in C, so that we'll need them. We'll need this stuff for the code we're going to be writing later in the semester. So we're going to talk for a little while just about pointers in C, because we'll need that skill, that information, to be able to do some sophisticated stuff later in the semester with the Windows operating system. So that's code that's in this zip file, and then there'll be another zip file later this week on some more stuff. Now, let's see. I think pretty much everybody's in. Before we start talking about, well, let me down that. Before we start talking about what's in there, does anybody have any questions about the homework assignment? Anybody had a chance to look at it? Have any questions so far about the homework assignment?
Professor, I have a question.
Uh-huh.
So there's actually two questions. So I'm having trouble with the environment when variables. I try to put them through even through the settings and the what to call in this computer and the Windows properties, and it's
No,
just
you don't want to do anything like that. No, do not do anything like that.
I have a second question as well.
Yeah. Do not touch the environment variables inside this computer.
I'm curious, what should I do in that case?
Well, okay, you use this command. Where is it? Here. That's how you set an environment variable. You open a command prompt. Again, everything is about the command prompt. That's the command prompt. So you open a command prompt and you type set myvar equal hello. Okay.
Mm-hmm.
Then you say set, and there's myvar. Okay. See, I created that environment variable.
Oh.
It's all done at the command line. So these environment variables live inside the command line. Yeah. Now, if you go to my computer, there is some stuff about environment variables. Let's see if I can remember where it is. Advanced systems.
Yeah, that was advanced system.
Yeah. And see, I don't want to log in as administrator and do it. No, you don't. Please don't touch that stuff. You could mess up your computer. Yeah, this has got nothing. If I needed you to set system admin, I would say that in the homework. If you needed to be going to my computer and setting systems, setting things that need administrator privileges, I would tell you that. Yeah, there's no mention of anything like that in here. So you're just using the command line. Okay. What else?
My second. Oh,
Hold on,
go ahead.
can people hear me?
Yeah, sure.
Yes, we can hear you.
Okay, cool. I was wondering, it says that these meetings are recorded, and I kind of missed the first one. I was wondering where I could find those.
YouTube.
They're right here.
Okay, thanks.
Yep. Okay, right there. Everything is on this course website. Okay, so there's a link to the first lecture. There's a link to the second lecture. There's a link to the third one, and this one will be replaced. This will get replaced by a link to today's lecture after class. Okay, so everything is here. Everything's on the course website. Okay, all right. So another question.
Yeah, there's actually it says that we're supposed to submit on Brightspace, but there's no actual assignment.
Yeah, send me an. You're right. I forgot to create the Brightspace tool for that. Send me an email after class to remind me, because I'll probably forget again.
Okay.
Yeah, Send me an email to remind me to create a Brightspace tool for the homework assignment. Thanks. I forgot that. Okay. Well, other questions?
Yes. My second question was, what order is the parameters? Because it was a bit confusing. It looks like it's group size, then columns and width, but in the example, it's the opposite for something like that. So I'm a bit confused there.
Oh, what is the okay, there's 3 parameters, right?
Correct.
They have an order on the command line and an order in the config file. They don't have order in environment variables. Environment variables are not ordered, okay? So there's no first, second, and third environment variable. But there is a first, second, and third in the config file. There is a first, second, and third value. And in the command line, there's a first, second, and third value. And I thought I ordered them the same. If I didn't point that, I thought they were ordered the same way. Let's see.
May
I'm looking where I thought
may I mention where I thought it was confusing?
Yeah,
Go down. That area right there. It was that
Ooh.
part. Yeah.
Ooh, okay. What do I have here? Boy, I thought I had this written correctly, but you're right. The order is real important, and I tried to make it consistent. But when I'm writing all this stuff, it's easy to get goofed up. Did anybody notice? Does anybody agree? Do I have these in the wrong order? Did anybody notice? Because off the top of my head, I don't remember what order they're supposed to be in.
The may I add that the way I was saying it from what I was reading in the beginning, it should be group size, then columns, and then width. But I'm not sure.
Yeah, that's what I think you're right. So this should be group size, so groups of 10. What was the second?
The second one was, sorry, I'm popping columns, and
How
then
many
width.
columns? Yeah. And then how wide a column is.
Correct.
Well, yeah, that's what I remember. That's the order too. Why? But I mean, yeah. See, column length here would be at the end. That'd be the third one.
That's why it kind of threw me off. I was like, wait a minute, hold up.
Well, yeah, but see here, the environment variables don't have an order. So this is the first and second, and then the third parameter came from the environment variable. And here the third parameter is on the command line. First, second.
So in command line, it doesn't matter what order, or it
No,
does?
no, the order matters here, but you don't have to have all 3 options. See, on the command line, you don't have to have all 3 of them. There might just be 1, there might be 2, or there might be 3 arguments on the command line. The command line, there's 3 arguments, at most 3 arguments, but there don't have to be 3 of them. So if there's 1, it's the group size. If there are 2, it's group size and number of columns. If there's 3, it's group size, number of columns, column width.
Right.
But you don't have to have all 3 of them on the command line. You can have 1, 2, or 3. You can have 0, 1, 2, or 3. In the config file, I specified that all 3 values were always there, just to make it easier to read the config file. In the config file, the rule is if the config file exists, it must have 3 values in it. If your program doesn't have to check for how many values there are, your program can just assume there's 3 values in the config file. But you don't have to. You do not assume there's 3 values on the command line. The command line can have no values here, 2 values, 1 value, or 3 values on the command line. Okay. But you're right. The order matters. The order matters in the config file, and the order matters on the command line, but the order doesn't matter with the environment variables.
Okay. Perfect.
Okay.
Thank you, Professor.
Okay. Any other questions? Any other question about the homework or anything else so far?
So for that, would it be like like for example, you can't have two to represent the, say, the first and third one. It just goes whatever, so it would recognize it as the first and second. So if you wanted,
On the
like
command,
say just,
you talk about the command
yeah,
line. Yeah, you can't do first and third.
okay, so
To
you'd have to
do
put all
that,
three if you wanted to get to the third one.
yes. If you want first and third, then you have to do stuff like they do in sophisticated programs. You have to give them named arguments. So you'd say things like filter, and you'd say column equal and width equal. You know, you'd have to give them names. Or if you did it Unix like, you'd say minus column equal, you know, minus width equal. See, then you could do first and then you could do them in any order you want. That's why programs like dir, when it takes its options, they're all named. See, that's why the options have names to them. So you could do them in any order you want. So you can say dir slash a slash w. Okay. Or you could do dir slash w slash a, means the same thing. You can also do you can even combine them together. Oh no, you can't combine them together in Windows. Yeah, you have to do them separate. In Linux, you can usually combine them together. Those are what we call named arguments. Yeah, you give the arguments names and then they can be in any order. Here, to keep things simple, the arguments are not named. So that means that they go by their order. So the first one is group size, second one is number of columns, third one is column width. And since they're not named, they have to, it's just like functions. You know, in functions, when you call a function, if a function takes 1, 2, or 3 arguments, you can't have the first and third argument to a function. Okay, all right. So to keep things simple, I left the arguments unnamed, but then the order matters. Okay, in most real Linux programs and most Windows program, command line arguments are named, and then by naming them, they can be in any order. But then the parsing of the command line is a lot more work. Yeah, it becomes a much trickier to do things. Okay, so this is actually, believe it or not, this is keeping it simpler. Okay, but yeah, you can't have, like on the command line, you can't do group size and column width and skip this one. You can't do that. And some Unix and Linux programs are like that too. Some programs do expect their arguments on the command line in a specific order, though by far and away the more common way to do it is named arguments, so they can be in any order. But and in Linux, they actually have special libraries to make it easier to parse all the command line options, because it can be a lot of work to read a command line and parse all the values on it. Okay, all right, okay. Any other questions on homework? Any other? These are good questions. So, you know, if you have questions, you can send me email, but I'll try to remember to start every day with people who can get asked questions. Anything else?
Hey, Professor, within the paragraphs of the homework assignment, it looks like the first command line's width, then number of columns, then group length.
Okay, sure. It does look like there's one of them that's different.
Yeah, the 3 paragraphs where you explain each
Here? Oh,
each
you mean
one.
when I'm saying it in words?
Yeah, when you say it in words.
Oh, you remember which paragraph?
Let me see.
Here's where columns goes. Okay,
Um,
okay, columns would be the second value in the config file and the second command line argument. Okay. The width of the command line should be oh, yeah, there it's mixed up. It says here in the config file, the width. There it is. Yeah, it's wrong there, isn't it? Here it says the width is first, and here it says that the groups is third. Ooh,
Yeah, I see that too. Yeah.
yep. Yeah, I think, yeah, you're right. I think the width and the group are these two are, I think these two are reversed. Okay, yep. I'll have to straighten that out after class. I'm pretty sure that what we said earlier is right and that these two are reversed. Okay, I have to look at my code, my source code, you know, the sort, but yeah, it looks like I got it reversed in these two paragraphs. Okay, someone send me an email reminding me to fix that. Yeah, that would, yeah, send me an email, remind me, and I'll fix it right after class. Okay. Yeah. See here, we're using the width of the no, it's no. Let's see. Maybe I was saying it wrong down here. Length is the length of a group, right? So that's third, and this is the width.
Hey, Professor.
Yeah.
In the test result correct text that came with that homework,
Mhm.
it is showing on it that it's with columns and length. So that seems like it's right, isn't it?
Okay. Yeah. So I think this is width, columns, and length of a group, right?
Right. That's
Width
what
of the columns, number of columns, length of a group. And that's what it says up here. First parameter is the first command line argument is the width. The third command line parameter is the length of a group. And that's what it looked like in the config file, in the example.
Yeah, that's right.
I hope I have it right here. You have to read this real carefully. I mean, this later on, we'll start looking at documentation for Linux and Windows. And if you'll notice that when you read the real documentation for Windows and Linux, it starts reading like a legal document. They're trying to be, like what I'm trying to be here, really careful to be precise and not make a mistake. And you end up having to write like a lawyer. Yeah, because you're trying to be incredibly precise, and it doesn't make it easy to read. Legal documents are notoriously hard to read, and the specification of a program turns out to be notoriously hard to read because it starts reading like a legal document. So these specifications are not easy to read. So and they're not easy to write. And I'm trying real hard to make sure that I got all the things correct. And I thought I had everything correct because I thought I proofread this a bunch of times. So I'll check it after class, but yeah, it does look like the thing I made a mistake about was getting these arguments wrong here. It is column width.
So,
Mhm.
so does this mean you're extending it?
No.
Professor, so go back to the top.
Yeah.
So this is where I noticed the confusion started. So go to after the second box, that first couple lines where it says the filter C program requires the three parameters. One parameter determines how many input numbers get grouped together. And then the
Yeah,
other
but that's
one,
not order. That's just saying there's one parameter. See, that's not numerical order. That's the English language. One parameter. That's not first parameter. That's one parameter. Another doesn't mean second parameter.
so I'm a bit confused then because I took it that as
Well,
the order.
that's the trouble with, you okay. if this contradicts what's clearly said down here, see, first of all, this doesn't say first parameter. First of all, it doesn't say first parameter where. It's not saying in a config file or on a command line or an environment variable. It's just saying that one of the parameters determines how many input numbers get grouped together. Another parameter determines the output columns. It's not specifying order, because it's not even specifying where they come from. See, now when I specify where they come from, like on the command line, then it specifies the order on the command line. When they come from the config file, then it specifies the order in the config file. That's like I was saying, you have to read these really carefully. You can't just read a line, make an assumption, and then stick with it. You have to read, compare with that, with what you, it's just like reading a legal document. But I can show you Linux documentation, the man pages. It's where you have to parse these things super carefully. Okay. And here I'm not, this word one does not mean first. Okay. And this word third just means a third parameter. It's not saying third in order. I mean, the English language sometimes is got its own ambiguities here. One doesn't mean first, and third here just means the third parameter, not third in any order. Because first of all, I'm not specifying here where the arguments come from a command line, from a config file, or from an environment variable. Okay, so I'm pretty sure this is consistent. I'm pretty sure that everything in here is written correctly. But as I mentioned last week, it's not easy to read. Yeah, and if when you start reading, I keep saying this again, when you start reading Linux command line pages or Windows function specifications, you'll see how hard it is to read them, because you have to parse them really carefully. You have to keep making sure that you're not assuming something the document didn't say. You have to make sure you don't assume something that wasn't really said in the document. Like this paragraph is not saying order on the command line or order in the environment, hasn't even said anything about command line yet or config file. So this is not order in a command line or a config file. And I think the rest of the document, I'll check it, I'll go through it again after class, but I'm pretty sure everything in here is consistent. But if anybody finds something that isn't, let me know. But I'm pretty sure everything in here is consistent. Okay. Yep. Part of computer science, specifications are essentially, specifications actually almost in some situations, specifications are legal documents. Okay. It's actually not unusual. They're contract / legal documents. Specification, when you're hired by somebody to do something, they'll give you a contract that specifies what you have to do, and it becomes a legally binding document. The specification, the contract, and the stuff has to be worded real carefully. And of course, it isn't usually, and that's why there's lawsuits left and right, because people do end up goofing up and writing things ambiguously. But it's something, yes, it has to be read very, very, very carefully. Okay, and it should be, these 3 paragraphs should be where things are really spelled out carefully. This paragraph specifies what's in the config file. This one specifies what's on the command line, and this one specifies what's in the environment variables. So these 3 paragraphs should be the ones that are that specify things carefully: config file, command line, and environment variable. And then the rest of the document should be consistent what's within these 3 paragraphs. That's the tricky part, making sure that these are the specifications, and then everything else should be consistent with them. And I think they are. So I thought I proofread this a bunch of times. But if you think something specific is messed up, please let me know, because it's not easy to do this stuff. Okay, it's not easy to write it. It's not easy to read it. But that is typical of any time you're working on software. You have to be precise about what's being required. Okay, any other question?
Then just to make sure, the parameter order should be with, and then I forgot what was the other 2.
Well, what does it say here?
Give me a second. I'm loading this. With
if the config file exists, the first integer in the config file is width. Okay, on the command line. Okay, and if there's a command line parameter, the first command line parameter is the width. Okay, so the width of the column is the first command line parameter and the first argument in the config file. Okay.
Okay. Thank you, Professor.
Yeah. Then the third value in the config file is the size of a group. The third command line variable is the size of a group. Okay. So yeah, these three paragraphs should be the specification, and everything else in this page should be in agreement with what's in these three paragraphs. This one specifies the config file. This one specifies the command line arguments. This one specifies the environment variables. Yeah. Config file, command line. Okay. All right. And like I said the other day, this is not an easy homework assignment. It's not a long homework assignment. You won't end up writing much code. Yeah, but there's an awful lot of details. Okay, a lot of details packed into like one page of code. It's really only about one page of code, but lots of details. Okay. Okay, so now let's look at what's inside this file here, working with composite data. Okay.
Hey, Professor, I have one more question.
Sure.
So with in the command prompt, I'm able to do like the source .exe to a filter program to a text. How would I do text document to filter to a new text document? I can't figure that one out.
Oh, I'm looking to see if there was, I thought I had an example like that on this page. Okay, here's where filter takes input from a text file. See, this tells filter to take input from a text file. And this, see, this says source on an output file. So if you wanted to do, let's see. Let me download the homework. I didn't download it yet. Okay, if I open a command prompt here. Okay. Yeah, source, whoops. Oh, source isn't compiled yet. Okay. Source generates that. So that puts results in a text file. Okay. The greater than symbol sends things to a text file. Okay. Then filter can take things from that text file. Oh, filter demo. Okay. Oh, there was only one number in that file. That was weird. The file only had one number in it. Okay, so there's a bunch of numbers in temp. And now there's the, okay. Now, then here, I can put the output in a second text file. So run filter, take input from that file, send output to another file. Is that what you meant? Is that the command you wanted?
Yeah, that's what I was looking for.
So
Thank
it
you.
read this file and it wrote that file. Okay, so, and this is true for any function on a command line. You tell, there's the program that says the program should take its input from there, and that says the program should send its output to there. And the order of those doesn't matter. These are so I can do filter demo, send the output to temp3.txt, and take the input from temp.txt. Notice that it doesn't matter what order you do. You can do input followed by output, or you can do output followed by input. The order doesn't matter. Okay. See, now there's the temp3. Okay. So what's important is this symbol means what's next is the name of the output file. This symbol means what's next is the name of the input file. So you could have input, output, or output, input. And Linux is exactly the same way. This syntax was stolen from the Linux operating system. So Linux uses this symbol just like Windows does, and it doesn't matter what order you put the files in. You can specify the input file, then the output file, or the output file, then the input file. And this is true for all programs. So for example, I can say dir, but I want to keep a copy of my directory listing, so I can say dir.txt. See, now I've got a convenient printout of what's in that directory. See, people, this is how people get printouts a lot of times of information on their computer. Just issue a command on the command line and send the output to a file. Right, so this works with any program, any command line program. This idea works with any command line program. Redirect input, redirect output. Okay. And so you can do this with the filter program or with the source. Well, source doesn't take any input, so you can't direct input to source. Source only generates output. So every time you run source, it generates output. And if you want, you can save that output in a file. Okay. Filter takes both input and output. So you could give it input or you could give it output. You can give it one or the other. You can give it input without giving it output. You can give it an output file without giving it an input file, or you can give it both. Okay. And if you don't give it either, now it's filtering what's on the command line. Okay. So now it's filtering what's on the command line. Oops. Okay. Okay. Other questions? Anything else? The command line's really important. Get used to using the command line. If you're at home on a computer, try practicing these lines like when I'm typing things in. Do it yourself so you get used to using the command line. It's an incredible skill. You know, if you have the command line skill, you'll make yourself more marketable. You know, it's just becoming because of cloud computing. It's not like people are ditching their GUIs on Windows computers and Macs. That's not at all the case. But more and more work is being done in cloud environments. And cloud environments right now don't have GUI interfaces. They might in a few years. You know, right now they don't. You know, the way people use cloud environments right now is almost entirely command line driven. You know, maybe in a few years they'll give the GUI, just like they gave desktop operating systems a GUI interface 20 years ago, 30 years ago. They might give cloud systems a command line, a GUI interface, but I have a feeling they're not going to. I have a feeling that the cloud will remain a command line environment probably for quite a while. I think that's just kind of, it's just more convenient for people that way. Oops, what happened here? What do you see on my desk? What are you seeing in Zoom right now?
The command line and the windows, the
Oh,
files.
you don't see, okay, I got a weird pop-up window just popped up on me and I don't know what it was. So you don't see this pop-up window. It says select a win, okay.
No.
Oh, okay. Yeah, because Zoom popped up a window on me and I wasn't sure if you were even seeing it. Okay. I wonder what that was. Okay. All right. So practice the command line. Start getting used to the command line. I put some references in here for command line help. Okay. Some of these references are pretty readable. And it's to your benefit to start getting used to this. You know, there'll be a lot of ways with the homework assignment give you something to practice the command line with. Yeah, to read about the command line, it's just like programming. If you read about Java and never write a Java program, you won't learn Java. You'll only learn programming by doing it. So you're only going to learn the command line by using it. So reading about it is worthless if you don't use it for some purpose. So that's why I try to make the homework assignment really use the command line so that you have something to do with the command line. Reading without doing is really useless. It's just a waste of time. But if you read and then go over here and practice with the homework assignment, you have the filter demo and the filter program to practice with a little bit. Okay, I'm sorry, the source program and the filter demo program you can practice and play around with. So use the command line, do practicing with it. It will help you in the long run. Okay, and the future homework assignments are all going to be command line oriented. You know, all the homework assignments in this class will be, because the operating system is pretty inherently itself a command line. You know, the GUI sits on top of the operating system. It's not the operating system. So the operating system really is command line driven. Linux is like that also. Even Android is. There's a command line on your cell phone. I don't know if any of you have ever seen it, but there's a command line on your cell phone. You can open a box like this on your cell phone and type commands. And it's used sometimes by people for debugging purposes, but it's actually there. Android is itself also a command line driven operating system. Okay. All right. So now let's switch to the this folder on composite data. Okay. Now, first of all, what do I mean by composite data? Composite data are when you bundle data together. So the easiest example of a composite is a string or an array. An array is a bunch of, if you have an array of ints, you have a bunch of ints bundled together. If you have a string, you have a bunch of characters bundled together. So we call that composite data. Now, arrays and strings are all the same kind of thing. An array is all a bunch of integers, or if you have an array of doubles, it's just all doubles. The other kind of composite data are structures or objects. Like an object can hold an int and a double. You know, so it's a bundle of stuff, and the bundle can be both an int and a double. So they don't have to be the same type. So arrays are homogeneous composite data types because an array holds all ints or all doubles. Objects and structures are inhomogeneous composite data types because they can hold mixtures of things. So a struct can hold one int, one double, and a string. Okay, so when you're working with composite data in C, you almost always work with it using pointers. Okay, and we'll see why. But once you once you start working with bundle, the main idea is, suppose you take an array of 1 billion ints. You don't necessarily want to make copies of that thing. So if you want to pass it around, you don't pass around copies of it, you pass around pointers to it because it's just too big to copy. An int is easy to copy. So if you need to pass an int from one function to another, you just pass the value itself. But an array of 1 million ints is too big to want to copy. So instead of passing a copy of the array, you pass a pointer to the array. You tell somebody, here's where the array is. Instead of saying, here is the array, you say, here's where the array is. So instead of passing the value, you pass a pointer. Okay, that's the idea we want to get used to, that you can either give somebody a value, meaning a copy of something, or you can give them a pointer to it, a reference to it. Okay. Now, here's something I want to show you that another thing that's involved with this. Okay, here's a program I put up on the Java visualizer. Let us watch this program execute. Okay, here's something that you don't know. Well, see a line of code like that, and see this line of code like that. Syntactically, they look alike. You're just saying something like A equals B. You're just saying that something equals something. Something equals something. The trouble is those two don't mean the same thing. In general, if I ask you, if I'm interviewing you for a job and I ask you, what does X equal Y mean? And if you give me an answer, I'm suspicious, because you should say, I have no idea what that means. You do not know what X equal Y means, okay? It depends on the language. And more than that, it depends on what kind of variable X is and what kind of variable Y is. This is, over here, we're going to see that this here means one thing and this means something else. Okay. And it's got a lot to do with this, what we mentioned a minute ago. Do you give me a value of something, or do you give me a pointer to something? Okay. Are you giving me the thing itself, or are you giving me just a reference or a pointer to the thing itself? When you do this, it depends a lot on whether X is a value or a pointer. Is Y the value of something or a pointer? Okay. Okay. Now in this Java visualizer, I can run this program by clicking on Visualize Execution. Okay. Then I can step through the program. Okay. X1 is 0, Y1 is 0. Okay. X1 is 3. Okay. Now notice that what this did was it took the value of X1 and copied the value into Y1. So if I back up, see, X1 has the value 3, Y1 has the value 0. This line is going to copy the value of X1 into the variable Y1. Okay, that's pretty easy. That's kind of what you expect in mathematics. Now, if I change X1, X1's different than Y1, because now I put a different value into X1. Okay, now down here, it's going to be a little bit more complicated. X2 is going to be a pointer to an object. See, X2 is a pointer to an object. Y2 is a pointer to another object. Okay. See, instead of X1 is a value, Y1 is a value, X2 is a pointer. Java calls them references. In C, we'll call them pointers. Y2 is a pointer to a value. Okay. Now, what does the next line do? Oh, now we're going to put values in them. Okay. Okay. Oops. Now I get to this line here. Well, what does this do? This makes the pointer in what it copies the pointer in X2 into the pointer in Y2, and it makes them point to the same value. Now, when you change X2, you're also changing Y2. Okay. So this made Y2 and X2 essentially the same thing. This made them hold the same value. This made X1 and Y1 hold the same value, but they're different things. This made Y2 and X2 the same thing, the same object. Okay, so this piece of syntax and this piece of syntax had very different meanings. After you've executed this, X1 and Y1 they're not tied to each other. If you update X1, it doesn't have anything to do with updating Y1. But after you execute this, X2 and Y2 are tied to each other. They're the same value. They point to the same object. If you update X2, you're updating Y2 also. Okay, this has real important implications for everything we're going to be doing. The key is that these are values. These are pointers. Okay, X1 and X2 are values. Y1 and Y2 are pointers, references to a value. Okay. So something as simple as what's X equal Y? What does that mean? If somebody asks you, what does X equal Y mean? You should answer, well, it depends a lot on what programming language you're talking about and what the data type of the variables are. Because even in the Java language, what X equal Y depends on whether X and Y are primitive data types or reference data types. Okay, and if you in the C language, that could mean something different. In a Haskell language, it could mean something different. what X equal Y means depends a lot on the language. There's no uniform meaning for assign. This is called assignment. We call this the assignment operator. There's no uniform meaning of assignment in computer science. Every programming language has its own idea of what assignment means. And Java essentially has like two different versions of assignment. We'll see that C has three different versions. The C programming language is even more complicated than Java. It's got several different notions of what it means to say X equals Y. And we want to start getting a feel for that. Because when you're reading a C program, if you see somebody just write, you're reading a C program and you see A equal B, you have to know what that means. And you don't know what it means until you've asked yourself, what is the data type of A? What is the data type of B? Okay, you have to ask yourself, what's the data type? So if you're reading a C program, you have to ask, what's the data type of A? What's the data type of B? If you're reading a Java program, you have to ask, what's the data type of A? What's the data type of B? Otherwise, you can't just say, well, let's A equal B. Well, what does that mean? A equal B doesn't mean let A equal B. It could mean let A point to the same thing that B points to. That's what it meant here. Let Y point at the same thing that X points at. Here it meant copy what's in X into Y. So this copied from here over to here. This said, let this guy point to the same thing this thing points to. Okay. So the equal sign had slightly different meanings here and here. Okay. And essentially the difference is that this is a composite data. Now notice that in this case, the object only holds one int, but it's an object. It could hold lots of ints. I could make that object hold a double. I could even let it hold a string. Okay, that object can hold a bunch of stuff. Okay. See now how the object is composite. It holds a bunch of stuff. And that's why Java makes these things pointers. When an object could hold a bunch of stuff, the object could get big. Like this object could hold millions of numbers. And Java doesn't want to copy big things. It doesn't want to copy composite data structures. So Java, instead of copying them, just says, here's where it is. It's willing to copy a number like 4 from one place to another, because that's real small. 4 is it's just a 32-bit, it's just 32 bits. This object could be, I can keep making this object get bigger and bigger and bigger and bigger. Okay, I can put as much data in this object as I want, and it can grow to be something huge. And so Java is designed not to make copies of composite data, not to copy big things. Okay, it only copies the primitives, and the primitives are small things. The primitives are ints, doubles, chars, and those are by definition very small things. It won't copy arrays. It won't copy objects because those are potentially big things. An array of 3 ints isn't very big, and this object's not all that big. It's not all that big. So it wouldn't take much, it wouldn't be hard to copy these small objects, but Java just says, well, objects can be arbitrarily large, so we'll never, actually Java will never copy an object. In C++, you're allowed to you can copy an object or not copy objects. In C++, composites like this can be copied or they can be referred to, pointed at. In Java, you can only point at them. You can't ever copy them. So in Java, whenever an equal sign is setting 2 references to each other, it's making one reference point to the same thing the other reference points at. It's making copies of the arrows, not making copies of the data. It's making a copy of the arrows, not making a copy of the data. Okay, and that's an important design of the Java programming language. And C and C++ have that same idea. that they want to be very careful about not copying really large data. The difference is in C and C++, for the most part, they leave it up to you. If you want to make a copy of a large piece of data, C and C++ will let you. Java won't even let you make a copy of a large thing. It'll always use a reference. C and C++ kind of leave it up to you. You probably don't want to make copies of big arrays, but if you got a 1 million item array and you need a copy of it, you can. It's easy to do it in C++. Java makes you can make a copy in Java, but it's not going to be by the equal sign. In C++, the equal sign can make a copy of an array. In Java, an equal sign can never make a copy of an array. You have to write a method to copy an array. But in C++, if you do things a certain way, you can make a copy of an array just by writing something equals something. Okay, so C++ lets you automatically make copies of big things. Java never does. Okay, now let's start looking at some examples in C that are built around these ideas. Equal sign, the difference between pointers and values. A value actually in the variable versus a pointer in the variable to a bigger value. Okay, so there's the variable, there's the value. The variable holds a pointer to the value. There's the variable, there's the value, the variable holds the value. In Java, that's called a primitive type. The variable holds the value. This is called a reference type. The variable holds a reference to the value. Okay, C and C++ give us a little bit more control over this. In Java, primitives are value types, objects are reference types. Okay, in C and C++, we have a little bit more control over those things. Okay, so now let's look at some examples here. Okay, here's an example. It's a little bit like the Java one we just did. Here's a strut that holds an int, a double, and a char. Okay, it's a little bit like this class that held an int, a double, and a string. Okay, I put 3 things in a class. Notice classes can hold methods also. C struts can't hold methods. They can only hold data. So this strut called example holds an int, a double, and a char. It's a lot like a class in C. Okay, now here's an instance of that strut. So it's called S1, and it's initialized to 5 in the int, 6.7 into the double, and 8 into the char. This is sort of like calling a constructor in Java. So I'm declaring a variable and I'm giving it a value. Okay. Now in Java, when you declare a variable of type class, you get a reference variable. Okay. You get a pointer. See, the variable does not, notice that this data can't be put over here. I can't stick this data over in here. I have to hold a pointer to the data. That's not the way C++ is, the C is going to work. This variable actually just holds that data. Okay. Now, here's another example. Here's S2. It holds a slightly different bit of data, 1, 2.34. Okay. Here's an equal sign. We're going to ask, what does that do? Now, here's something that's going to be a little bit different. This is going to be like what Java does. This is going to be a pointer to the data. This is how in C I get this picture here. Here's the pointer to the data. I get that automatically in Java. If it's a object, I have to point at it. Here we're going to see that if they have an object, I can either point at it or hold the value of the object. Okay, so now what I want to do is I'm going to take now this program. If I run it, you can't see what it's doing, But there's just like there's the Java visualizer here that lets us watch a Java program run, there's a C++, there's a C visualizer. Okay, it's called the C tutor. C tutor. Okay, oh, let's see there. C tutor, visualize C code. Okay, there's a reference to it in this folder. The folder we downloaded, there's a reference in this folder to the C tutor website and to the Java tutor website and the Java visualizer. There's two different visualizers for Java. One's called Java tutor and one's called Java visualizer. There's one for C called the C tutor. Okay. Now, what I can do is I can take my program and copy it from the text editor and copy it into the visualizer. Okay. So now the code, now I can watch it run just like I watched code run in the Java visualizer. So click on Visualize Execution. It's a little bit slower than the Java one. Okay. Now, here's a visualization of Java's memory. Here's a visualization of C's memory. And it's a little bit more complicated. Okay, let's go through the code and see how this came about. Okay. This says what a strut example looks like. It holds an int, a double, and a char. Okay. This creates one, a global one. See, this is outside the main method. That's this guy here. S1 is a global variable. Now notice S1 is not pointing at the data. S1 is the data. So this strut is acting like a primitive in Java. S1 is the data. So S1 is this large object, okay? Then down here, now that's a global variable. In main, I have local variables, S2, S3, S4, S5. Here's S2, S3, S4, S5. See the question marks? They haven't been initialized. The program's at line 13. The computer is essentially at line 13. It hasn't started stepping through this code. The global thing is initialized when the program loads. Okay, that's like static variables in the global variable in C is like the static variables in Java. They are initialized as soon as the program starts up. So this program is started, but it's at line 13. The global variable is already initialized. This variable here is about to be initialized. There, see, 1, 2.3, 4. Like this global variable, S2 is the data. It's a data value. It's a lot like these primitives. Okay, again, in Java, there's no way to have a variable hold a bunch of data. If a variable wants to hold a bunch of data, the variable must refer to the bunch of data. But in C, you're allowed to let a variable hold a bunch of data. Okay, the variable holds, in this case, an int, a double, and a char. They're all bundled together in that one variable. Okay, now the next line of code is going to initialize S3. Okay, S3 holds different data. Okay, no, I'm sorry. Now what happened here was S2 got copied to S3. See this equal sign here? It acted like this equal sign, not like this equal sign. In Java, the only way you can, in Java, when you have primitive variables, you copy from one variable to the other. When you have reference variables, you copy pointers. Okay, see how these pointers got copied to the same value. Over here, when I wrote S3 equals S2, it copied this value into that variable. It copied this variable and this variable. If this variable had actually held 1,000,000 bytes of data, this thing still would have copied all the 1,000,000 bytes of data. Okay, this is what Java doesn't want to do, but C will let you do it if you're kind of dumb enough to. If this strut held 1,000,000 bytes of data, this thing here would copy 1,000,000 bytes of data. If this strut held 1,000,000,000 bytes of data, this thing would copy 1,000,000,000 bytes of data. It would copy 1,000,000,000 bytes of data from here to here. Now, you may not have enough memory to hold all that data, but like my computer has like, I don't know how many, 8 gigabytes of memory. So it would have enough memory to hold 1 billion bytes of data. And this assignment would have copied from 1 billion bytes of data to another billion bytes of data. Okay, so here the equal sign actually copied the value from S2 into the value of S3. Okay, now the next line does something funny. The next line acts a little bit like these arrows here in Java. The next line creates an arrow. See, S4 points at this block of data. S4 holds the address of S3. So S4 points at the block of data. Okay. Now S5 is going to do something funny. Now notice over here, you point over to this is called the heap. This is called the stack, and this is called the heap. You point over here into the heap. Notice what I have here is a pointer in the stack pointing to an object in the stack. These objects are in the stack. Java never lets you put an object in the stack, ever. You can never put an object in the stack. Only primitives and pointers can be in the stack. Now what I'm going to do is I'm going to put an object in the heap. That's this line of code here. It mallocs some memory in the heap. Okay, so now this guy is sitting in the heap, just like this guy's sitting in the heap. So I've noticed I can do almost everything in C that I can do in Java, but I have to do it a slightly different way. Okay, so now I've got a reference in the stack pointing to an object in the heap. Okay, now I can start manipulating these objects. So like S3 is this object here. I can change what's in the A variable of it. When I change S3, I'm also changing S4 because S4 points at it. Okay, so I just updated this variable here. So if I go back, see, it was 1, and I'm updating it to 100. Okay, now notice I changed the value in S3, and by default, I also changed what S4 holds because S4 is pointing at the same object. Okay, and then if I print these out, so I'm going to print out S1, S2. To print them, I have to print them. There is no toString in Java, in C. So if I want to print these 4 objects, I have 1, 2, 3, 4 objects. I have to essentially print them using printf, and I print what's in S1, print what's in S2, print what's in S3. Notice S4 and S5 are pointers, so I use a slightly different syntax. S2A is S2.A. S2's B is S2.B. S2C is S2.C. Okay. Now, what about S4? The A in S4 is S4 arrow A, because you have to follow the arrow to A. S4's B is S4 arrow B, because notice that the syntax is real clever. It looks like a little arrow. S4 is a pointer. You have to follow the pointer to the object and then look inside the object to get the value you want. So you say S4 points at a thing, and then I want the B in that thing. S4 points at a thing, and I want the C in that thing. And then S5 is also a pointer, so I use the same syntax for S5. I don't say S5.A. If I say S5.A, I'll get a syntax error. I say S5 arrow A, because S5 is a pointer. I have to point at the object and then get what's inside. See, in Java, you don't use that kind of syntax. In Java, you would say y2.n, y2.z. You don't have to use this arrow because Java, the arrow is by default. It's automatic. So Java knows that x2 is a reference. So if you just write x2 dot something, it'll automatically give you the x2.z is that thing. In C, I have 2 kinds of objects. I have objects in the variable, and I have objects pointed to by the variable. Okay, an object pointed to by a variable. Now this object is kind of quirky. It's in that variable. It's pointed to by that variable. The same object, here's the object. It's named S3, and it's pointed at by S4. So I have this line of code here and this line of code here. both refer to the same object. This stuff here and this stuff here refer to the same data, but two different ways, through its name and through its pointer. Okay, and if I execute these, they print out up here. So there's the data in those objects. Okay. Okay. All right. So in C, things are kind of a mix up between what you see in Java. What you see in C is a mixture of what you see in Java. In Java, primitives are values, references are pointers. In C, primitives are values, but objects can be either values or pointed at. You can point at an object or you can name the object. An object can be a value or the object can be the target of a pointer. Okay. In Java, an object's always the target of a pointer. Objects can only be the target of a pointer. They can't be the value of a variable. Okay. But you get used to the idea that a reference variable's value is an object. But it's something you have to be very, very careful about. If you've had me in other classes, in Java, I've told you over and over again, don't say that X2 is a my class. Don't say that Y2 is a my class. Say that X2 refers to a my class and Y2 refers to a my class. Because see, by the end of this program, X2 and Y2 refer to the same object. By the end of the program, I don't have two objects. I only have one object. I have two references, but only one object. So if I say that X2 is an object and Y2 is an object, I would be mistakenly thinking that there's two objects. But by the end of my program, I don't have two objects. So X2 is a reference to an object. Y2 is a reference to an object. At the beginning of the program, there are two objects, but at the end of the program, there's only one object. At this point in the program, there's two objects. X2 is a reference to this one. Y2 is a reference to that one. But by the end of the program, there's only one object left, but there's still two references. In C, it's more complicated. There's an object. Well, okay, here's an object. It's got a name. It is S3. S3 is that object. S4 is a pointer to that object. So here I have both of them. See, over here, X2 isn't an object. X2 always is a reference to the object. In Java, in C world, I can have S3 is an object, but S4 is a pointer to an object. S5 is a reference to an object. Oh, and here's something interesting. S5 is a reference to an anonymous object. That object doesn't have a name. S4 is a reference to a named object. The object has a name, it's named S3. When you allocate things in the heap, they are anonymous values. And people use those ideas a lot. You'll hear people refer to anonymous classes, anonymous objects a lot. They mean things in the heap. No, there's no name to this guy. S5 is not his name. S5 is a pointer to him. Just like S4 is a, see, this guy does not have two names. This guy has one name, S3. He also has a pointer to him. The pointer is not his name. S4 is not the same variable, not the same type of variable. S4 has the type pointer to strut. S3 has the type, it is a strut. S3 is an example. S4 is a pointer to an example. This is confusing. X2 isn't an object. X2 is a reference to an object. Unfortunately, Java makes you actually think a little harder. If you think in Java like you kind of think it is, like X2 is an object, Y2 is an object, you get messed up and you write code that's wrong. If you say to yourself, X2 is an object, eventually you'll make some kind of mistake because X2 isn't an object. It's a reference. And in C, you have to keep track of everything. S3 is the object, S4 is pointer to the object. S5's pointer to the object. In the case of S5, the object itself is anonymous. Okay? It's an anonymous object. Notice I never initialized it. I never put anything in it. You notice that the program crashed when I tried to print S5. The program crashed. This is the typical. I did this on purpose. This is unlike in Java where there's constructors and everything is initialized automatically when it's allocated. In C, malloc allocates objects and leaves them uninitialized. You have to do something else to initialize them. There's no automatic notion of a constructor in C. So I purposely left this guy uninitialized. When he tried to print it, the program crashed because it couldn't print. There was, see, conditional jump or move depends on uninitialized values. So the program crashed because this stuff wasn't initialized yet. Okay. All right. So this is the kind of stuff we're going to be talking about a lot. This distinction between an object and a reference to an object, a strut and a pointer to a strut. In Java, clear distinction between primitive variables which hold values and reference variables which can only hold pointers to values, and the values are always in the heap. Okay, primitives hold values, reference types hold pointers. They point to things in the heap. The objects must always be in the heap. C gives us a lot more variability. We have variables that actually hold an object in the stack. We have objects in the heap, and we can point at, now if the object's in the heap, you can only point at it. If an object's in the stack, you can either give it a name or you can give it a pointer. Okay, there's a name for this object. It's got a name and it's got a pointer. Anonymous objects in the heap can only be pointed at by a pointer. Okay, and the equal sign here. Now there's a couple, see this equal sign here and this equal sign here did different things. This equal sign copied S2 into S3. This equal sign copied a pointer, an arrow to an arrow. Okay, it copied an address into an arrow. Okay, and this equal sign also copied an arrow. It created an arrow. See, these are S4 and S5 hold arrows. So these equal signs put arrows into pointers. This equal sign put, these two equal signs put a value into a variable. Okay. All right. So now notice this visualizer lets us see this. Eventually, you have to get to where when you read this code, you just know what it's doing. The visualizer lets us watch, but your goal is to be able to read this code and mentally build that picture we just looked at. Same with Java. Your goal is to be able to read this code and mentally build the picture that these are references to objects in the heap. Yeah, here you read this code and you start thinking, okay, there's a global variable with that value. It's not a pointer. That variable holds that strut. Here's a variable in the stack that holds that strut. This is another variable in the stack, and it's holding a copy of this stuff. This got copied into here. Okay, so you, whoops. So you read this as, oh, copy whatever is in S2 into S3. Then you read this as, oh, this is a pointer in the stack pointing at a value in the stack. A pointer in the stack pointing at a value in the stack. Here's a pointer in the stack pointing at a value in the heap that's uninitialized. Doesn't have it, the value doesn't have any values in it. It's been allocated, but it hasn't actually been given values yet. So it's a pointer in the stack pointing at memory in the heap that hasn't been initialized yet. Okay. All right. So now let's look at another example. Here's a similar example using strings. Now, strings are just arrays of characters. So this is essentially using an array. So you can think of this as an example using a string, or in Java, strings aren't really arrays, they're objects. In C, strings are literally arrays. They're a special kind of an array. Okay. What I want to do is copy this into the C visualizer, and let's kind of let's watch this thing, what it does. Let's watch what it how it behaves. Oops. Oh, So just real quick, we're out of time. But if you compare this program to the previous program, they're set up very similar. See, there was a global strut. Here's a global string. Then there was some local struts. Here are some local strings. Okay. Just real quick, let's just visualize it and then we'll quit. We've run out of time, but just let you see the picture of this real quick. See, here's what memory looks like before the program starts. The global thing's initialized, the stack things aren't. Okay, but that is going to, see, the string is going to sit inside the stack. The characters of the string, the array is sitting in the stack. This array is sitting in the stack. Here's going to be an array that, see, now I have an array in the heap. There's an array in the heap. So I have a global array, local arrays in the stack, and an array in the heap. Okay, so we have to start paying attention. And then the equal sign will have different meanings depending on whether something is a value in the stack or it's a value that's pointed at. Okay, so this is the we'll pick up with this on Wednesday. There's a lot of details going on here. The Java, the C language and the Java language don't act alike. And code that looks, in language, you have this notion of false friends. When a word in one language is the same word as in another language, but they don't have the same meaning. Java and C are like that. You can write a line of code in Java that's also a line of code in C, doesn't mean the same thing. Lines of code like this don't have to have the same meaning in Java and C. Okay, so you have to be very careful about the meaning of everything you read. And that's what we're going to be talking about. We're going to talk about more and more about the meaning of these lines of code, and we'll compare Java with C a lot. Okay, anybody got any last minute question with this? Any question about these two examples? Download this folder and start playing with these examples and copy them into the visual. Do like I did here. Practice doing that. Open the file in an editor, copy and paste it into the visualizer. Use the visualizer to step through the code. I'm sorry. Use the visualizer to step through the code and watch what it does. And start thinking mentally about what do these lines of code mean and what do they actually do. So practice doing these things. Okay, so we'll do much more examples of this on Wednesday. Okay, so we run out of time, so I'll just end the meeting. Any last question? Oh, there's something in the chat. Okay, all right, so see you on Wednesday. Bye-bye.